Today we're on pages 146 and 147 of our textbook. It'd be helpful if you had a highlighter, and a calculator is only going to be used for our basic operations. Lesson 2, Arithmetic and Geometric Sequences. We're going to review two particular sequences. The first, an arithmetic sequence, which is based on a constant addition to get the next term. And the second is geometric, which is based on a constant multiplier to get the next term. It's very important. Now, you worked with both of these sequences in Algebra 1, and whenever you're talking about an arithmetic sequence, you're adding the same thing to get the next term. Now, that addition could be a positive number or a negative number. And when you're talking about a geometric sequence, you're multiplying by the same number to get the next term. And again, that multiplier could be a whole number, or it could be a fraction, in which case, if you're multiplying by a half, that's the same as dividing by 2. First, looking at an arithmetic sequence, the explicit formula is a sub n equals a sub 1 plus n minus 1 times d. Now, this is what is given to you on the formula sheet, the second page of your green colored table of contents, all right, on the back of the second page. So this was given to you at the in your textbook packet, is the reference sheet for the Math Regents exams. So here it is. Here's your arithmetic sequence formula, and it's given to us in subscript notation. A sub n equals a sub 1 plus n minus 1 times d. And then right beneath that is a geometric sequence. A sub n equals a sub 1 times r to the n minus 1. It also can be written in function notation, which is f of n equals f of 1 meaning the value of the first term, plus n minus 1 times d. Now, what is d? D is the common difference, or is also can be thought of your constant addition. All right. Now, how do you get the common difference, the d value? It's the difference between two consecutive terms. What if you don't have consecutive terms, right? If you don't have consecutive terms, then what we would do is to find d. Let's see, if we had let's say the fifth term and the third term, we would take the value of each of those, their difference, and subtract the number term of each. So it's kind of like the slope, right? So in general, d would equal, if we had a sub y minus a sub x over y minus x. Exercise number 1 asks us to generate the next three terms of the given arithmetic sequence. Well, what type of sequence is this? Well, looking at it, right, meaning is it explicit or is it recursive? Okay, so this is how it's defined. So this is the first term, and this is the so-called like rule or formula. So there's two pieces to this, right? There's two parts. And a sub n is equal to a sub n minus 1. Now, a sub n is the value of the nth term. A sub n minus 1 is the value of the term previous. So this is a recursive arithmetic formula. We want to generate the next three terms. Well, we have the first. What's the second? Well, again, interpreting the recursive into words, the current term is equal to the previous plus a half. So the previous is 3 halves plus a half is 4 halves, which is the same as 2. And the third term would be the previous 4 halves plus a half, which is 5 halves. So the next 3 terms, we have the first 3 terms. And given the first, the next 3, the fourth term would be the previous 5 halves plus a half, which is 6 halves. So there we have our next 3 terms, 4 halves, or 2, 5 halves, and then 6 halves. And 6 halves is the same as 3. Find the first 4 terms of the given arithmetic sequence. Okay, so let's see, what type of arithmetic sequence is this? Is it explicit or is it recursive? F of n is equal to 2 plus 6 times n minus 1. Oh, no, let's see. So the value of the nth term equals 2 plus 6 times n minus 1. Even though there's n minus 1 is there, it's not preceded by an f, all right? So this is an explicit arithmetic sequence. If we want to find the 10th term, we would just put 10 in for n. We want to find the first 4 terms, so we start off with f of 1 is equal to 2 plus 6 times 1 minus 1. We just substitute 1 in for n. That is 0 times 6 is 0, so f of 1 equals 2. F of 2, the second term, would equal 2 plus 6 times 2 minus 1. 2 minus 1 is 1, times 6 is 6, plus 2 is 8. F of 3, 2 plus 6 times 3 minus 1. That's 2 times 6 is 12, plus 2 is 14. And f of 4 is 2 plus 6 times 4 minus 1. 3 times 6 is 18, plus 2 is 20. So here we have 2, 8, 14, and 20 are the first 4 terms of this sequence. Next, consider f of n equals f of n minus 1 plus 3 with f of 1 equal to 5. Okay, so this is a recursive sequence, right? We have this rule where the current is equal to the previous plus 3, and we have the first term's value. So this is recursive. Determine the value of f of 2, 3, and 4. F of 1 equals 5. F of 2 equals, I'm going to use my words, it's the previous plus 3. So the previous is 5 plus 3, which is 8. F of 3 equals the previous plus 3. The previous is 8 plus 3, 11. And f of 4, the previous 11 plus 3 is 14. We want to write an explicit formula for the nth term of the arithmetic sequence that we have here. Based on the first term, f of 1, which is 5, d, so what's the common difference, and n. So let's see. Let's write the formula from above. F of n equals f of 1. By formula, I mean the formula up here, plus n minus 1 times d. And the first term is 5. The value of the first term is 5. What's the common difference between 5 and 8, and 8 and 11, and 11 and 14? 8 minus 5 is 3. plus n minus 1 times 3. And this is our explicit formula. If I wanted to find the value of the fourth term, right, we just put 4 in for n. 4 minus 1 is 3. 3 times 3 is 9. 9 plus 5 is 14. Checks. Using your answer to B, find, oh, so now it's asking us to do just that, to check. I already checked f of 4, so let me just check f of 3, all right, on paper here. So f of 3 is going to equal 5 plus 3 minus 1 times 3. Just substituting 3 in for these n's here. 3 minus 1 is 2. 2 times 3 is 6. 5 plus 6 is 11. So that checks. Exercise number 4. Given that a sub 1 equals 6 and a sub 4 equals 18 are members of an arithmetic sequence, determine the value of a sub 20. Okay, so to find D, the common difference, think of average rate of change. So this is what I kind of mentioned above, what happens when you don't have consecutive terms in your sequence. So as it states here, think of average rate of change. All right, so we have the first term and the fourth term. So D is going to equal, the common difference would be a sub 4 minus a sub 1 divided by 4 minus 1. So in this case, 18 minus 6 divided by 3. 18 subtract 6 is 12, divided by 3 is 4. So D is 4. We want to find a sub 20. All right, so using the formula, and again, it's much more preferable that you it's in subscript notation. I just find it easier to work with it in that notation as opposed to function. So the formula is a sub n equals a sub 1 plus n minus 1 times D. Now we simply make our substitutions because we want to find the value of a sub 20. So a sub 20 equals a sub 1, the first term is 6, plus n is 20, minus 1, and D is 4. 20 minus 1 is 19. Well, actually, that's 19 times 4 is 76, and 6 plus 76 will yield 82. So the 20th term is 82. Something like this can always be checked on the calculator. If I put the our formula in as 6 plus parentheses x minus 1 and then 4, then look at the table of values. The first term, right, its value is 6. The fourth term, its value is 18. And the 20th term, let's see, its value is 82. Next, let's look at geometric sequences. Now, geometric sequences have a constant multiplier. And again, the formula here, this is the function notation. On the reference sheet, it's in subscript notation. So I prefer the subscript notation. So a sub n equals, let's write that down. A sub n equals a sub 1 times r to the n minus 1. So r is the constant multiplier, where r is the common ratio and can be positive or negative and is sometimes a fraction. So to find r, you divide two consecutive terms. Generate the next three terms of the geometric sequences given below. A sub n equals a sub 1 times r to the n minus 1. We want the next three terms. Let's put our and replace a sub 1 with its value 4 and r with its value 2. I'm sorry, there's not much room here. Okay, so the first term we know is already 4. So the second term is going to be 4 times 2 raised to the 2 minus 1. That's 2 times 4, which is 8. The third term is 4 times 2 raised to the 3 minus 1. That's 2. 2 squared is 4, times 4 is 16. And the fourth term, I'll try to squeeze it up here, is going to be 4 times 2 to the 4 minus 1. 4 to the third is 8. I'm sorry. Yeah, 2 to the third is 8. And 8 times 4 is 32. B, f of n equals f of n minus 1 times a third, with f of 1 equal, okay, this has two parts to it. This is a recursive geometric sequence. So since it's recursive, the current term, write the words current equals f of n minus 1 is the previous times a third. So the constant multiplier is a third. The first term is 9. The second term would equal the previous, which is 9, times a third, 3. The third term equals the previous, 3 times a third, 1. And the fourth term equals the previous, which is 1 times a third, 1/3. C, looking at this 2 has two parts to it. It's got kind of the rule and the first term. And the current term is equal to the previous times the square root of 2. So the current equals previous times square root of 2. The first term is 3 square root of 2. The second term would be the previous, which is 3 square root of 2 times the square root of 2. And the square root of 2 times square root of 2 is 2. It removes the square root symbol. And 3 times 2 is 6. The third term is the previous 6 times the square root of 2, which is just 6 square root of 2. And the fourth term, the previous 6 square root of 2 times the square root of 2 is going to be 6 times 2, which is 12. Our last exercise is asking us to determine if the sequence is arithmetic or geometric, and then to write an explicit formula and a recursive formula. Okay, so the terms of the sequence are 1, 3, 5, 7, 9. Is there a constant multiplier or a constant addition? What are we doing? We're adding 2. Okay, so this is arithmetic. The formula for an arithmetic is a sub n equals a sub 1 plus n minus 1 times d. What is a sub 1? It's the value of the first term, which in this case is 1, plus n minus 1. The common difference is 2. You're done with the explicit formula piece. Now the recursive part the first term, its value is 1. We said, what do you do to 3, or sorry, what do you do to 1 to get 3? You add 2. So the current term equals the previous plus 2. So we write the previous as a sub n minus 1 plus 2. Make sure this is a subscript here, okay? Next, we have the terms of the sequence 2, 4, 8, 16, 32, where we definitely see we are multiplying by 2. So since it's a constant multiplier, this is geometric. The formula for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. Our first term, so a sub 1, the value is 2, times r also happens to be 2. We'll do this to the n minus 1. Recursively, first term is 2. We take the previous and multiply by 2. A sub n minus 1 times 2. Or a nicer way of writing it is to write it a sub n equals 2 a sub n minus 1. Next, we've got negative 2, 1. I see addition of 3 here. Adding 3. So that means it's arithmetic. A sub n equals a sub 1 plus n minus 1 times d. So a sub 1 is negative 2 plus n minus 1 times 3. Recursive, first term is negative 2. The current term equals the previous plus 3. If a sub n represents the current, then the previous is a sub n minus 1. And here in number 4, we're multiplying by 10, timesing by 10. So this is geometric because there's a constant multiplier. Geometric, a sub n equals a sub 1 times r to the n minus 1. A sub 1 is 1, r is 10 to the n minus 1. Recursively, first term, 1. And if the current term equals 10 times the previous, or the previous times 10. 10 times the previous. 10 times a sub n minus 1. I thank you for your attention today.